Okay, hello everyone. So I hope everything is okay. So I'm just going to discuss briefly how to graph tangent functions. Okay, although we already discussed this before, I just want to ensure that you recall everything in graphing tangent functions. Okay, so let's start. So let's try to recall first the parent function, which is y equals tangent x, and this is the graph, right? So we already discussed before. So we know that there are vertical asymptotes at negative pi over 2, and we also have the vertical asymptote at pi over 2. And aside from that, we also have the three critical points here. We have at pi over 4, 1, we have at 0, 0, and at negative pi over 4, negative 1. So you have to remember this parent function. Okay, so basically, so this is our parent function graph. So let's start answering one example here. So we have y equals 2 tangent of 1 half x minus pi plus 1. So number one step here is you should know how to find the vertical asymptote. I mean the vertical asymptotes. Okay. And you also need to remember how to find the period. The period in a tangent function is given by p equals pi over the absolute value of b. So let's start now first by identifying the vertical asymptotes. So how can we find the vertical asymptote? So first, take a look here. We have 1 half x minus pi. So we will be getting this portion of the function or of the equation. So 1 half x minus pi. And we're going to equate that with negative pi over 2. Why negative pi over 2? Because it is where the graph started in our parent function, right? It's from negative pi over 2 to pi over 2. So we equate that with negative pi over 2. So we will try to find the value of x, and that will serve as our vertical asymptote. So look at the function or the equation rather. Their common denominator is 2, so you can multiply all the terms by 2. So 1 half x times 2 is x, because 1 half of 2 is 1, and 1 times x is x, right? And then we also have 2 times pi is 2 pi, so we have x minus 2 pi, and it's equal to, same thing, so negative pi over 2 times 2 is negative pi. So just multiply everything by 2. Then from there, we add both sides by 2 pi. So you will get x equals negative pi plus 2 pi, and x is equal to pi. So pi now is one of our vertical asymptotes. So the second one is same procedure. We will still get the same expression here inside. So that's 1 half x minus pi, and we equate that we equate that with pi over 2. So same procedure. We just need to multiply everything by 2, and you will end up at, okay, x minus 2 pi equals pi, and x equals pi plus 2 pi, and you'll get x equals 3 pi. So these now are the two vertical asymptotes. We have at pi and we have at 3 pi. These are the vertical asymptotes. Okay? So in our parent function, we know that there are three critical points, and the y values there are at 1, 0, and negative 1. Now, where do we put all those critical points here? So one point is here. That's between pi and 3 pi, and that's 2 pi. We will put 1 point there. Then another point here, between 2 pi and 3 pi, it's gonna be here. So we put the point here. And also, another point is in between pi and 2 pi, it's gonna be here. And we put negative 1 here, the point. Now, we're not yet done, because by looking at the function, we still have 2 here and we still have 1. So which indicates that it will be affecting the y values in our graph. So the y value here is 1, the y value here is 0, and the y value here is negative 1. So we just need to multiply everything by 2 and add 1 to get the new points, right? So here, your y value is 1, right? So 1 times 2, which is 2, plus 1, and it's equal to 3. So instead of 1, we're going to translate that, translate that at 3. Okay? And also we have at 0, so we multiply that by 2, that's 0, then plus 1, still 1. There. And then the other one, that's negative 1, right? So negative 1 times 2 is negative 2 plus 1, and it's equal to negative 1, still negative 1. So we're now going to connect all the points smoothly. There. So that is now the graph of our function y equals to tangent of 1/2 x minus pi plus 1. So I had also given here the period. So by looking at the graph, this is already 1 cycle, okay? So what is the distance between pi and 3 pi? It's 2 pi. So we can now say that the period here is 2 pi. So let's verify using this formula. So pi over the absolute value of b. And our b here is 1/2, right? Because it's our c, this is our d. Okay, so we have period equals pi divided by the value of b, which is 1/2. It's gonna be here. So when you are dividing with fractions, you can just do this form or technique. We get pi, then multiplied by, we get the reciprocal of this, which is 2. So pi times 2 equals 2 pi. So really, we can say that the period here, or 1 cycle here, is 2 pi. Okay, and we will be needing this period later in identifying our domain. So that's still useful. So let us just try to write all the critical points here, or let's try to label them. So between 2 pi and 3 pi, this is 5 pi over 2, right? Because 2 pi plus 3 pi equals 5 pi over 2. So we're going to write there. So that's 5 pi over 2, 3. This is 2 pi 1. And this is between pi and 3, and I mean 2 pi, that's 2 pi plus pi is 3 pi over 2. That's 3 pi over 2. So that's 3 pi over 2, negative 1. So these are the critical points of our graph. So my next concern is how to get the domain. Domain are all the possible or the permissible values of x. So in this case, we can now say that pi and 3 pi are not part of our domain because they are the vertical asymptotes. The graph will just approach them, but they will never intersect that. Okay? So let's say, for example, one of the vertical asymptotes is pi. We know that one period is 2 pi. We can just add 2 pi, right? So pi plus 2 pi, you get 3 pi. That's why 3 pi is a vertical asymptote. Next, 3 pi plus 2 pi is 5 pi. So we can say also that 5 pi is not part of our domains. Let's say 5 pi plus 2 pi, 7 pi. So there are infinitely many numbers that are not included in our domains. So we should write that in a general form. So how can we write that? So the domain here are the set of all x such that x is an element of real number such that x is not equal to pi plus 2 pi n. Why pi plus 2 pi n? So I just copied this pi plus this 2 pi right here is 1 period, okay, times n. So that's now the general form. Or I can just write here instead of getting pi, I can just write 3 pi. So 3 pi plus 2 pi, that's a period, then times n, where n is an integer. Okay? For example, one period. So one period, so let's say n is equal to 1. 2 pi times 1 is 2 pi plus pi equals 3 pi. So there, 3 pi really is not part of our domains. What else? What if n is equal to 2? So we're now dealing with two periods, right? So 2 times 2 pi, which is one period, is 4 pi plus pi equals 5 pi. So really, 5 pi is also not part of our domains. So you have, since in a tangent function, there are infinitely many vertical asymptotes, not only pi, not only 3 pi. You have to write that in a general form. And as you can see, the range here are all real numbers because this graph can be extended infinitely upward, and it can also extended infinitely downward. Okay, so next I want you to practice. So you can pause this video, and after you answered it already, you can just play it again. Okay, so here are the answers. The period is equal to 2. So you just need to equate this everything by negative pi over 2 and pi over 2. Oh, so sorry. The period here is pi over 2 is equal to 2. Okay. So we have the vertical asymptotes at negative 2 and then 0. And then that's what I'm talking about earlier, that you have to get everything here and equate that to negative pi over 2 and pi over 2 and find the value of x. And that will now serve as your vertical asymptotes. Okay, what is next here? The domain. So here's the graph now. So please check your answers if it's correct. I hope you learned something here. Okay, enjoy answering another examples if you wish to.